So we'll now get to question 4. Given that f of x is equal to x into 5 minus x squared, determine the second derivative of x. So we're going to differentiate twice. Before we differentiate, we can expand. Let's expand. So f of x, let me expand the bracket. So it's x into 5 minus x times itself. 5 minus x times itself. So this would be x into expand. So first term square. That's, so remember, a minus b all square is the first term square minus 2 times the product of the two terms here, ab plus b squared. So we can apply the same principle here. 5 minus x squared. So the 5 would be like the a, and the x would be like the b. So we'd have 25 minus 2 times 5x, so minus 10x. And the final term square, that's plus x squared. So distribute the x to each term. So we have 25x minus 10x squared plus x cubed. So we can take the first derivative now. So this is f of x. So the first derivative, differentiate 25x, we get 25. Differentiate negative 10x, we get negative 20x. Differentiate x cubed, we get 3x squared. The second derivative, differentiate 25, we get 0. Differentiate negative 20x, we get negative 20. And differentiate 3x squared, we get 6x. So the second derivative is negative 20 plus 6x. Or you can write it as 6x minus 20 if you prefer putting the positive value in front. Next, differentiate each of the following expressions with respect to x. So I'm just going to let this be equal to y. So dy by dx would be equal to differentiate 2 sine 3x, differentiate 3x, we get 3, multiply it to the front, so we end up with 6 cos 3x, differentiate sine, I get cos, and differentiate cos x, you get minus sine x. Next one, again, we can let this be equal to y. So let me just break it up into product rule, so product rule, alright, so dy by dx, differentiate the, let me call this the 1 plus 2x cubed, let me call it u, and the x plus 2, let me call this v. Applying the product rule, remember product rule is u prime times v plus u times v prime, alright? So u prime, that would be 1 plus 2x cubed all differentiated. So where you applying the chain rule, so we multiply by the power, 1 plus 2x, subtract 1 from the power, we get 2, and then we differentiate the terms in the bracket. Differentiate 1, we get 0. Differentiate 2x, we get 2. So that will represent u prime. And then v is x plus 2. Plus, and then now we alternate. So this time, we're going to keep u, which is the 1 plus 2x all cubed. We won't be troubling that. And then we're going to differentiate x plus 2, which is a v. Alright, so x plus 2 is v, so v prime differential of x plus 2, that's just 1. Alright, so that is, I guess if we can write this, let's see, the 2 times the 3 give us 6. So I guess we can write this as 6 outside, and we have what, 1 plus 2x all square. And we still have x plus 2. So all we did here was multiply the 2 by the 3. And then plus, we have 1 plus 2x all cubed. And I'm sure we can leave it like that. or maybe you could factor 1 plus 2x. 1 plus 2x is a common factor there, but I don't see how that will make it any simpler. Determine the stationary points on the curve y equal x cubed minus 4x squared plus 4x. So to get the stationary point, we let dy by dx be equal to 0. So dy by dx would be 3x squared minus 8x plus 4, and we equate it to 0. So we can factorize. So if we're using the AC method to factorize this quadratic, AC is 3 times 4, which is 12. So we want two numbers that multiply to give positive 12 and add to give negative 8. That seems like minus 6 minus 2. So we can rewrite the middle term as minus 6x minus 2x plus 4 equal to 0. And we factor by groups. So for the first group of terms, common factor there is 3x. So we are left with x minus 2. The second group of terms, the common factor there is minus 2. And again, x minus 2. So notice we have a common factor there, x minus 2. So we factor out x minus 2. What are we have left leaving here now? Remaining x 3x minus 2 equals 0. So we can equate both factors to 0 and then solve. So x minus 2 equal to 0, or 3x minus 2 equal to 0. So x equal to 2, or so we add 2 to both sides and divide by 3. So x equal to 2/3. So now we need to find the corresponding values for y. So remember, look, here's the equation for y. So get the y corresponding y values. Now we substitute the x values. So we substitute x equal to 2. So we want the corresponding y values now. So we substitute. So when x equal to 2, so in this we're going to replace the y. We're going to replace the x with 2, sorry. So we end up with 2 cubed minus 4 times 2 squared plus 4 times 2. And this should give us y equal to, this is 8 minus 4 times 2 squared, that's 4 times 4 minus 16 plus 8. That should give us 0. Next we're going to substitute 2/3. So when x equal to 2/3, y equal to 2/3 cube minus 4 times 2/3 square plus 4 times 2/3. So remember y was what? X cube minus 4x squared plus alright. So when x equal to 2/3, 2/3 cube, 4 times 2/3 square plus 4 times 2/3. And I believe that will give us, let me see, (32/27). So the stationary points, so stationary points, see, to refer to as turning points, are, what are they? They are when x is 2, y is 0. So they are 2, 0. They are 2, 0. And 2/3, 32/27. So 2/3, 2, 0, 2, 0, 2/3, 32/7. Alright? Let me put them back here. So the stationary point are 2, 0 and 2/3, 32/27. over 27. So now next we're asked to determine the nature of each stationary point. And to do that we need now the second derivative. Remember the first derivative was, what's the first derivative? The first derivative was gx squared minus 8x plus 4. So the first derivative was gx squared. So we need the second derivative, which will be d2y dx squared. So the second derivative differentiate gx squared, we get 6x. Differentiate negative 8x, we end up with negative 8. Alright? So at x equal to 2, just in the first turning point there, the second derivative d2y by dx squared is equal to, replace x with 2, so 6 times 2, that's 12, minus 8, which is 4, that's bigger than 0, so therefore this would be a minimum when the second derivative is more than 0, so minimum, so this is a minimum point. Alright, at x equal to 2/3, so we're testing the other point. At x equal to 2/3, the second derivative d2y by dx squared is equal to second derivative 6 times 2/3, so it's 6 times 2/3 minus 8. So 6 times 2/3, that's 4. 4 minus 8, that's negative 4, which is less than 0, which means it's a maximum. Alright, so when the second derivative is less than 0, the turning point is a maximum. So the 2 zeros is a minimum, and the other point, 2/3, 32 over 27, is a maximum. Alright, so now we're at question 5. Integrate 4 cos theta with 4 sin theta. Integrate sine. Integrate sine is actually negative cos. Integrate sine is actually negative cos. Alright, so negative 6 cos theta. So this becomes 4 sin theta plus 6 cos theta plus c. Remember, it's an indefinite integral. We don't have any limits, so we'll add a constant there. Alright, next, integral, definite integral. Now we have limits. We can do several things here. We could use the reverse chain rule. We could expand. Let me expand. Again, expand 3 minus x squared. I end up with 9 minus 6x plus x squared. Alright. So expand the bracket and then I integrate, or you could have used reverse chain rule. It works either way. Shouldn't affect anything. So integrate 9, we end up with 9x. Integrate 6x. Integrate 6x, well, 6x squared over 2. That's 3x squared. And integrate x squared, that's x cubed over 3. So we add 1 to the power and divide by the new power there, right? So next step is to form 2 brackets. In the first bracket, we're going to replace x with 1. Alright, replace x with, first bracket, replace x with 2. So replace x with 2. So 9 times 2, that's 18. Minus 3 times 2 square, well, 2 square is 4. Multiply that by 3, negative 12. And then 2 cube, that's 8 over 3. In the other bracket, now we're replacing x with 1. So 9 times 1, that's 9. Minus 3 times 1 square, that's minus 3. Plus a third. So the first bracket works out to be 18 minus 12, that's what, 6. So that's 6 plus 8 over 3. Minus, in the bracket here, 9 take away 3, that's 6 plus a third. So if this thing jumping all over the place. So if I distribute that negative, I would have 6 plus 8 thirds. Distribute minus, was minus 6 minus a third. So 6 cancel negative 6. So end up with 8 thirds minus 1 third, that's leave it with 7 thirds. Next, we're asked to determine the area of the region bounded by the curve y equal 5 plus 5x minus x squared, the x-axis, the y-axis, and the line x equal 2. Let me do a little sketch there quickly. Alright, so we have the y-axis, we have the x-axis, they meet at 0. We're looking at a line x equal to 2. It should be a straight line like that. This is line x equal to 2. This curve here, look at this curve here, it's a quadratic. It will cut the x-axis at 5, right? It will cut the y-axis at 5, sorry, since the constant there is 5. So they should cut the y-axis at 5. Alright. So the graph should look something like this. Function looks something, so this is the area I want to find. Alright, notice the region x-axis 0, 2. So the area is the integral of y between the limits. And limits in this case, the x limits will be 0 and 2. Alright, so the area of the integral of y, which is 5 plus 5x minus x squared dx between 0 and 2. So let us integrate. So integrate between 0 and 2. Integrate 5, we end up with 5x. Integrate 5x, that's 5x squared over 2. Integrate x squared, that's x cubed over 3. Alright, so now we can substitute the limits. So we form two brackets. In the one bracket, we replace x with 0. The second bracket, we replace x with the bottom value 0. The first bracket, we replace x with the top value 2. So replace x with 2. So 5 times x, that's 5 times 2, which is 10. Plus, replacing x with 2. 2 squared, that's 4. 4 times 5, that's 20. 20 divided by 2, that's 10. So the 5x squared divided by 2 works out to be 10. And then minus x cubed, 2 cubed, that's 8 over 3. In the second bracket, replace x with 0. So everything will be 0 plus 0 plus 0. So all of that will be 0. Alright, so the area would be, let me just delete that. So the area would be 20 minus, what is this? 2 and 2/3. So it'll be 17 and 1/3. Alright, square units. Next, a particle moves in a straight line so that t seconds after passing through a fixed point O, its acceleration is given by, so the acceleration is given by 3t minus 1 meter per second square. When t is 2, the particle has a velocity of 4 meters per second and a displacement of 6 meters from the starting point O. Determine the velocity when t is equal to 4. Now, if we have acceleration, to get velocity, we can just integrate. So velocity is the integral of acceleration with respect to time. And the limits, we given our limits. Given the limits there. No limits, alright? With respect to time. So v is the integral of acceleration. Acceleration is 3t minus 1. So we're going to integrate that with respect to time. So we'll end up with v equal to, integrate at 1 to the power. So it's 3t squared over 2. Integrate 1t, well, negative t, plus the constant. So integrate acceleration to get velocity. And the question tells us that when t is 2, velocity is 4. So when t is 2, v is 4, so we can use this to get the value of c. So we substitute 4 for the v and 2 for the t. So it's 2 for the t, so it's 3 times 2 square. Now 2 square is 4. 4 times 3, 12. 12 divided by 2, 6. Minus t, and t is 2 again, plus c. So what we have here is 4 equal to 4 plus c. So the constant there is 0. So therefore the constant is 0. So which means that velocity is just 3t squared over 2 minus t. Alright, since the constant is 0. So this is velocity, and we found the constant to be 0. Alright, so we write it, so the constant there doesn't feature. Alright, so determine the velocity when t is equal to 4. So substitute t is equal to 4 to get the velocity. So substitute t is equal to 4. So v is equal to 3 times 4 squared. So 3 times 4 squared over 2 minus t, which is 4. And this works out to be, now 4 squared is 16. 16 divided by 2 is 8. 8 times 3 is 24. 24 take away 4 is 20. So velocity is 20 meters per second. Alright? And so note this, so this information served no purpose at all. We didn't need it to find our solution. Alright, let's continue. So we are now at the final section of the paper, the statistics part. At a school canteen, 80% of the students purchase chips. So I guess so C is chips, right? And 55% purchase chicken. Chicken is K. Alright, so it's chips and chicken. 11% do not. Let me see. Of the students who purchased chicken, 11% did not purchase chips. So over here we have 11%. This 11%. Alright, this 11% did not purchase chips. Alright, so any at all, so we put 11% over here. Of the students, so notice for chicken is 55%. So to make up the 55%, we need to put a 44% here, right? So it's 44%. Notice when you add 44 and 11, you end up with 55% for chicken. But 11%, this 11% did not purchase chips. So this would be chicken alone, 11%. Also, 80% purchase chips. Remember, chips is represented by C. So 80%. So to make up the 80% for chips, what's 80 minus 44? So this will be 36%. So let's double check it. So let's go over the question. So chips is 55, that's 44 and 11. Sorry. Yes, chips is 55. Alright, 44 and 11. But this 11%. What am I saying? Let's go again. 80% for chips. So we have 36 and 44. That's 80%, right? 55% for chicken, which is K. We have that, 44 and 11. But this 11% is only chicken. This 11% did not purchase chips. So that diagram is okay. Alright, let's move on. Determine the probability that a student chosen at random purchases only chicken or chips. So the probability of only chicken, only chips, or only chicken, so 36% for only chips and only chicken, that's 11%. At these we get what? At these we get 47%, or 0.47. Next, it seems to be conditional probability. So probability of A intersect B. So probability of A intersect B. So remember, probability of A intersect B is the probability of A plus probability of B minus the probability of A union B. And where this comes from? So we know that probability of A, the probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. And if there's some transposing here, you'll end up with what we have, what I just wrote above here. Alright? You can just swap these. Alright? Subtract PA union B from both sides and add PA intersect B to both sides. You end up with what I have there above. Alright? So the probability of A is a quarter. The probability of B is 3/5 minus A union B, that's 7/10. And of course I can, what's LCM here now? LCM is 20, so I can put each fraction over 20, a quarter. That's 5 times 1, 5 times 4, so 5. To get 20 here, multiply by 4, so 4 times 3, 12. And then to get 20 here, multiply by 2, numerator and denominator, so I get minus 14. Alright? So that's 5 and 12, 17. 17 minus 14, that's 3. So it's 3 over 20. Next, the probability of A given B. So formula for the probability of A given B is the probability of A intersect B divided by denominator here, probability of B. Now we just found the probability of A intersect B to be 3 over 20, and the probability of B is 3/5. So it's 3 over 20 divided by 3/5. So it's 3 over 20 divided by 3/5, which will be 3 over 20 times 5/3, right? So that into that, 1, 5/20, that's a quarter. So the probability of A given B is a quarter. Next, state with a reason whether A and B are independent. Now, if A and B are independent, then the probability of A intersect B should be equal to the probability of A times the probability of B. Let's work out the probability of A times the probability of B. Now the probability of A times the probability of B is equal to, what was the probability of A? The probability of A was a quarter, and the probability of B was 3/5. Multiply those, I get 3 over 20. And 3 over 20, of course, is not, no, 3 over 20 is not equal to the probability of A intersect B. So we can conclude that probability of A intersect B, which was, probability of A intersect B was what? Actually, A intersect B was 3 over 20. It was 3 over 20. So they are independent. So intersect B was equal to 3 over 20. So probability of intersect B is equal to the probability of A times the probability of B. Hence, A and B are independent. So part D, the following data shows the marks obtained by 27 students in a math test. Construct a stem and leaf diagram to display this data. So let's do this stem and leaf. Alright, so the numbers, so we start from 30. 30s goes up to the 90s, so we can, let's do a little table here. So this is our stem, and we have a leaf over here. Alright, so 30, so it's 3, and then we have 30, we have 35, and then we have 39, is it? And then for 40, we have 40s, we have 42, 45, 45 again. Then for the 50s, we have 50, 52, 59, 52, 59. Uh, 61, 61 again. Then we have 60, 65, 69. We have 70, 70, 70, 70, 71, 75, 77, 79. And then we have what else now? We have, so we have 81, 83, 83 again, 85, 87, and 89. Let me just separate my rows. And then we have the numbers in the 90s now. So we have 90, we have 90, two 90s, and we have 95 and 98. And if we should count all the digits in the leaf, we should get 27, since there are 27. And 27 students. Each digit represents a different number. We also need to put a key. You can just put in a random number to use as a key. Let me choose 35. So this means 35. All right. Let's move on. State one advantage of using a stem and leaf diagram to display the data. So a stem and leaf, I mean there are quite a few advantages. So a stem and leaf shows the range and the skewness of the data. So we can see what values the data leans towards, and so on. All right, that's one mark there. See the range. So range is the biggest number minus the smallest number. So remember, so if you look at the diagram, so the range, so the biggest number was 98, the smallest number was 30. So the range would be 98 minus 30. So the range would be 98 minus 30, which is what? That's a 68. Part 4. State two distinct observations about the data as seen in the box and whisker plot. We can make several observations. One of them is the range, as we just saw. We just say the range. So the data is shown as the range, 98, biggest number, 30, smallest number. So two observations would be the range. We can see the quartiles. We can see all the quartiles, right? The quartiles. The first quartile is 52. The second quartile is, or the median is 71. The third quartile is 63. All right. Those are at least two of the observations we can take from the data. All right. So that's it. That's it. End of paper.